Number 11 is actually a very special type of factoring. It's the difference of squares factoring. We saw this in our last lesson. If you just have two terms, a squared minus b squared, one of the easiest types of factoring that you'll ever have. Just take square roots of these terms. You'd get a and b, but you'd have an a plus b and an a minus b. Wonderfully, that's what you're going to see for number 11. What's the square root of 4? Well, I hope everyone would quickly say it's 2. You'd have to have a 2 and a 2. You just would have a 2x and a 2x. What's the square root of 1? Plain and simply, it's a 1. But of course, you're going to have 1 plus and 1 minus. Now, by the way, you could still do what we were doing earlier with the calculator. It would work. It would be fine. But this type of factoring, my goodness, you can do this so much more quickly, and that's definitely preferred. Let's take a look at number 12. Number 12 has maybe one of the biggest surprises to the factoring. Here we have x squared minus 20x plus 100. And, as we look this over, as we graph this, you can see it sure is looking like our parabola is, really out of sight. We're not seeing the other branch of it. And it looks like we're going to the far right edge here at 10, at x equals 10, or perhaps at x equals 9. And that can be a little worrisome. It sure looks like we're just going to be touching once. So tell you what, if we did second calculate, if we went to 0, we could say negative 10. We could say positive 10. Take a guess. Well, maybe guess x equals 10. Not a bad guess at all. You could see this 9.99999. Again, we've mentioned that before. Sometimes the calculator has a little bit of round-off error. And this is a perfect example of that. What you'd see is 9.9999999. It's really trying to say x is 10. Because our parabola would be touching just once, this is where we'd get our double root. If this was our answer, of course, for an equation like we were doing on the top for problems 9 and 10, we'd stop right here. But we're trying to factor. So you can see that we'd have x minus 10 and x minus 10 as your two factors. You're always, when you cross just at one point on the calculator, when it's just looking like it's going to be crossing at one location and then bouncing back, you're going to have identical parentheses here. The parentheses are, in fact, the same. So x minus 10, x minus 10. Of course, here's something so important. You can always do a check. You can, if you're nervous about it, you could actually FOIL. You could multiply this all out to make sure you're right.